Good morning. I am Mr. Live and I would like to discuss to you the K-related tests, specifically the repeated measures Anova. So my presentation will go through with the definition of the repeated measures design, the advantages, the disadvantages. We have three assumptions actually. We have the first, it must be independent, and we have the normality assumption, we have the sphericity assumption. Then we're going to apply and we're going to generalize this. So first of all, when we conduct the repeated measures Anova, that means the measurements of the subjects are done several times. It means, for example, we have 5 subjects or participants. These 5 participants will undergo some treatment, or say, first measure, then after some time with the time element, enough time, these 5 again will undergo another measurement or another observation, and a certain time again this 5 will undergo another observation and a series of observations. That means these subjects, these 5 subjects, underwent several measurements. So this arrow represents enough interval or time interval, and so that this one is not affecting the other. And these 5 individuals are not related. The one is not related to the other. There is no, this 5 or does not affect the other one. So it means these 5 are working independently and they are independent to each other. So we have to define first the repeated measure Anova. So we have here before, during, and after. Repeated measure Anova, or say repeated measure design, is an experimental design that measures each participant on the dependent variable multiple times. It means that you are conducting an experiment and this individual or participant or subject were measured multiple times. So, and each time the participant is measured, he or she experiences different levels of the independent variable or factor. You are using different treatments. That means you need to verify first that the other one has no effect on the other. So this is known as the within subjects factor. Repeated measures have different names. The first is called within subject design. And this is how it is going. So we have here the sample, and these samples will undergo the treatment A, and we've got after some time they will be treated with treatment B. For specifically, this is also known as the extension of Prt Test. It means when we have repeated measures Anova, it is more than the Prt Test. We are not just doing 2 pairs, but we are doing 3, 4, or more pairs of variables. So we have here, for example, we have 6 subjects, and we conduct pre-test, all of them. Then we conduct the controls. So for example, you are a certain treatment or drugs, or say we have the control first. It could be in a form of a placebo or any control that is agreed by the researcher. Then this arrow represents a certain direction that you need to test after a certain protocol, of course. Then after ng testing, all of them will undergo the treatment A, then another test, and after the testing, after some time, this arrow represents time interval, treatment B will be administered or is administered. Then after that, we'll have the post-test. So there are a lot of tests or measures. We have here the test for the control, test for the treatment A, and test for the treatment B, and as well as the test of all from A and B. This is different from the between subject design, because in the between subject design, you are going to split or separate the samples into 2 categories or more categories, in which you are going to having the point of comparison. But in the within subject design, you are comparing. So there are advantages when you are using the repeated measure Anova. The first is, according to Soskin and Holland, it is unbiased. It's because although you are only having one group and then you are testing that group, you don't need to test that group in pre-test and post-test alone, because that will give you a bias, of course, because there is no point of comparison. But if you are going to have the repeated measures, that means you are going to do a series of observations that becomes unbiased. It's because when there is consistency of the result, then that is really consistent, that is effective. Repeated measure is efficient according to Mazumdar and Mitsodis and Ma. It's because you can save money, of course. It is also advantageous when random assignment is not possible. A limited number of persons or groups, and it requires fewer participants than between all subjects, of course. Kasi makakatipid ka kasi hindi mo siya hiwalayin, kundi lahat sila. Okay. Then, also, obtaining participants is expensive actually, and participants are hard to find. So these are the advantages. Disadvantages, of course. There are also disadvantages of repeated measures ANOVA. The first one, it is time-consuming. Kapoy, nakakaubos ng energy. Why? Because it takes time until you will end. And because of the time element, time requirement could affect attrition rates. Baka marami nang hindi mag-continue sa iyong experiment. So, ano ang gagawin mo pag may lumipat or hindi na gustong magsali doon? So, that is a problem. And also, since we have a little number of samples, unlike sa between, it is not be as generalizable to other populations. And maybe the treatment A could affect the treatment B, or the treatment B could affect the treatment C, and that means there is a carryover or practice effect. So what we're going to do to minimize or to lessen this one? So the first is, sa attrition rates, of course, para maging motivated sila to undergo the experiment, we have some monetary incentives, or it could be a gift, or it could be that depends on what you're capable of. Para naman hindi sila ma-stress, we need to have the rest periods. That means give them enough time, rest period before the treatment A or before administering another treatment. I need to have the rest period. Or just to lessen the carryover or practice effect, you have your intervals, time intervals in between treatments. And one way to control carryover is the counterbalancing. So how to do the counterbalancing? So this is it. We have the group 1 and 2. Since we have 3 treatments, A, B, C, and we have 6, then we can divide 6, divide 3. That means by pair of 2. So group 1 and group 2, they will undergo treatment A, and group 3 and 4 undergo treatment B, and group 5 and 6 undergo treatment C. Then after that, group 1 will undergo treatment B, group 2 will undergo treatment C, and group 3 will undergo treatment A, group 4 undergo treatment C, group 5 will undergo treatment A, and group 6 will undergo treatment B. After a certain time interval again, a group 1 will undergo treatment C, and so on. Then after that, you have So this is applicable to treatments, but if you are having a spiral lesson, of course, it is not applicable. It's because it is spiral, it must following a certain pattern or difficulty. But if you can have the counterbalancing for a certain experiment, then it's okay. This counterbalancing also has a disadvantage or a side effect. And one of these is the latency effects. Why? Because the latency effect actually is an effect of treatment that is not evident until a second treatment is introduced. So it means late effect actually could be the result of some problems in here. How to mitigate or lessen this latency effect? The one way is to allow adequate time enough time between treatments to prevent latency effects. Say for example, we have here a set of data, treatment A, B, C, and D, with 4 participants, where A is a tablet actually that is for time of relief. That means the highest number, it means the better relief. And we have here treatment A, we have 1 hour, 2 hours, 3 hours, 5 hours. For treatment B, we have 2 hours of relief, and so on. For letters, you have 3, 5, 4, 6 hours, 6 hours. For treatment D, we have 4. So that means these participants underwent treatment A, then interval, adequate time interval, then treatment B, adequate interval, treatment C, another interval of time element, and then treatment D. So what are the assumptions that we need to verify when we conduct the repeated measures ANOVA? First of all is in independence. So each of the observations should be independent. That means collaboration is possibly not in here. It's because when you have collaboration of effort or groupings, so for example, you are teaching method, then there is a grouping, that means the other one is affected because of the interactions. So first, it must be independent, okay? A repeated measures ANOVA assumes that each observation in your data set is independent of every other observation. So how to determine if this assumption is met? So the first is you have to check random sampling method. So titingnan natin kung naka-random sampling method ba tayo. What if kung hindi naka-random sampling method or hindi siya independent? So that means that is a really serious issue, and that can lead to an increased type 1 error. When you say type 1 error, it means you are rejecting the null hypothesis even if it is true. Cooperative learning, of course, is not allowed in here. Then the only remedy for this is to recruit. If there are problems with independence, that means you have to recruit and you have to make them independent. The normality, so the distribution of the response variable is normally distributed. The response variable is normally distributed. How to determine if normally distributed? Of course, you can visually check using the QQ plot or the histogram. And if you are going to create a histogram, you have to check visually if it is following to the bell shape. If it is not, then it is approximately, possibly not normal. So this must be the shape, parang bell shape siya. If you are creating a QQ plot, see to it that the points fall on a straight diagonal line. If they do, they can typically assume that the normality assumption is met. So for example, we have this data. I have here the data of treatment A, treatment B, and treatment C. I have to go to the descriptives. I'm using the JASP, the Jeffrey's amazing statistical program. So we have here to identify the descriptive statistics. Then you have to look at the plots. We'll use the QQ plots. Then titingnan natin what happened. So in here, we can see that treatment A follows a normal line, a straight line diagonal. Then treatment B is not actually. Then for C is following and D is not. So how to do that one? Actually, makita din natin na yung ating yung statistics natin. Titingnan natin by Shapiro-Wilk test. So by Shapiro-Wilk test, we can see that in here, the treatment A is 0.85 the p-value. So it means it's normal. Treatment B is not, and treatment C is normal, and treatment D is not. So we can see here, actually, makita natin siya. It's 0.85. If this is not significant, it means it's normal. Dapat mas malaki. So that is our treatment A, B, C, and D. So napaka-klaro that your treatment A follows a normal. This one is not. This one is following the normal. And this one is, because of this, it's not normal. There is, according to Cohen 2001, the test of normality is severely violates with a small sample size. So that means we need to have the non-parametric test or the data transformation. So this is how to do the second, in which you are going to conduct the Shapiro-Wilk test for normality, and if the p-value is less than, the data is not normally distributed, and if that is greater than the alpha, it means it is normally distributed. So in here, for this reason, it is often to inspect your data visually using graphs like histogram and PQ plots. By simply looking at the graphs, you can get a pretty good idea of whether or not this data is normally distributed. So what to do if this assumption is not met? The assumption is not met. We know that Anova is considered fairly robust against violation of the normality assumption as long as the sample sizes are sufficiently large. Pag maliit, itetest mo talaga. Pero pag malaki na, marami na masyado yung sample natin, that means pwede nating hindi test. I-assume na lang natin kasi madami na siya. So what to do with the assumption is violated? The first one is you're going to transform the response values of your data. So there are many ways how to transform the response values, but the most common and pwedeng makaya siya manually is you are going to use the natural logarithm of the certain data. So gamitan lang ng Excel. Then, or you can perform an equivalent non-parametric test such as Friedman test that doesn't require the assumption of normality. Actually, this is good. And I think we're done. So the third assumption is sphericity. When I say sphericity, it is the variances of the differences between all combinations of related groups must be equal. So in short, the variances of differences of all treatment combinations be homogeneous. In simple terms, we are going to meet a set of acceptable patterns that the subject should respond similarly across treatments. So what we're going to do that one is, for example, you have here the before the diet, person 1 to 4, after 2 weeks and after 4 weeks. We are going to subtract the first pair is this. So 102 minus 97 is 5. 79 minus 77 is 2. Then this is the difference for the first pair. Since there are 3 columns, then there are 3 pairs. We can do 3 pairs. So you have here the first and the third. So 102 minus 95 is 7 and so on. Then we're going to find the variance. So the variance of this is 10, the variance is 4, the variance is 3.33. Now, the test of sphericity, titingnan natin that these variances of differences for all treatment combination must be homogeneous. Kung yung difference ba ay homogeneous ba, or are they setting unacceptable patterns in which they respond similarly across treatment? So if this assumption is violated actually, then the F ratio becomes inflated and the results of the repeated measures ANOVA become unreliable. To test if the assumption is met, we can perform the Mock-List test of sphericity. The null hypothesis is the variances of the differences are equal. For the alternative, the variances of the differences are not equal. One, if the p-value is less than some significance, then that means we are going to reject, and therefore the differences of the variances are not equal. So that means pag maliit sa 0.05 or the set alpha, it means the sphericity is not met. If that is greater than the alpha, that means the sphericity is met. Depending on which statistical software you use, but in here, you will always see this Mock-List W, which is, so for example, we have this one, which is 0.356. Titingnan natin yung p-value. Since the p-value is greater than 0.05, and that means the sphericity is met, we would fail to reject the null hypothesis. And what to do if this assumption is violated? So if we reject the null hypothesis of Mock-List test of sphericity, then we typically apply a correct two ways how to correct the degrees of freedom. We can the lesser degrees of freedom, or you are going to multiply the degree of freedom by the epsilon. How to do that one? Of course, we have three corrections. The first is the Hein field, the greenhouse geyser, and the lower bound. So the most common among these is the greenhouse geyser, in which each of these corrections tend to increase the p-value in the output of the repeated measure ANOVA. In here, we know how to conduct the sphericity test. So I have here the four treatments, A, B, C, D. We have the levels 1, 2, 3, and 4. So I named it A, B, C, and D. Then we have the new factors since there are 4. So these are the repeated measure factor 1. So we have to select this one, and then we have to drag this into the repeated measure cells, and then we have here the result, of course, within, and we have the p-value there. Then we have to go to the assumptions checks, or assumption check. We have the sphericity test. So here we'll find the MAC-list W, and in the MAC-list W you will get the p-value, which is 0.0152. So since this is greater than the alpha, or the 0.01 or 0.05, then that means this sphericity test is met, or assumption is met. So from that, you will see that this one's sphericity assumption is met. So that means if the three assumptions were met, then we have to set this, of course, first we have to set the null hypothesis of the repeated measures, that all of the means are equal. And we say that the alternative hypothesis, at least two means are not equal. So we have to test the assumptions, and I think are independent. Then for the normality, we can say it is normal. Then sphericity, it is met. So next we are going to use the test statistic, and we have the analysis or the implications or discussion of results. So in here, you will see the k-related. So the degree of freedom actually is 3 and the residuals is 9. So the F value is 15.584 and the P value is less than 0.001. That means there is a significant difference among the 4 treatments. But the question is, which among the treatment is having a higher or better time of relief? We'll use and the data again, then we have to undergo the post-hoc test. The post-hoc test is used to identify kung saan sa apat yung maganda or yung statistically significant among the others. Kasi naman yung repeated measures ANOVA, titingnan lang niya kung meron bang kaibahan yung apat. But in the post-hoc, doon natin malalaman kung sino ko yung kakaiba, sino yung different sa kanilang apat. So in here, Tukey and Scheffé are not appropriate for repeated measures. That is according to Maxwell and Field 2012. So here we can see that the p-value according to Bonferroni, we have 0.066. So from A to D, when we compare A and D, it is significantly different. That means A is significantly different from treatment D, similar to B and D. So in here, we can get the result that A is significantly different to D and B is significantly different to D. Therefore, D is really different. Now, to verify further whether if it is true, then we have to use this descriptive statistics actually. So you can run this one in the JASP. Then you can see there that 6.75 is the mean of relief in terms of hours for treatment D. That means treatment A is really different with treatment D. As you can see, malayo ang kanyang difference. Treatment B and D are also different, but treatment C and D are not different. So it is statistically not different. So it means treatment D has a better time of relief among the treatments. So when we compare the one-way ANOVA and we say we have between group and within group, so we are using the variance between groups and the variance within groups. You are dividing that one. But under repeated measures, we must be careful because although we are still splitting the two total variation into between and within, but the within is divided into two. We have the between subject variation and the error variability. So the error variability is our variance in error, which is our denominator. So this is the difference. And usually, the variance in error is less than. So that's why, if we have here the result, and then pag nagkakamali tayo, we use one-way ANOVA, yung p-value niya is 0.72, then we say it is not significant. But actually, since it underwent with the repeated measures ANOVA, kasi you conduct or administer different treatments or you observe at different times, then it is found out that since the error here is 2.89, the mean square, and this is our denominator, then you will see 12.46, and the F ratio with a p-value of 0.0073, which is less than the alpha 0.01 or 0.05, it means there is a significant difference among the treatments. This is an example actually. So it means we need to be careful that repeated measures ANOVA is for repeated measures. And another way, what if nagkakamali tayo doon sa gusto natin siyang gamitan ng non-parametric. So the equivalent of the repeated measures in the non-parametric is the Friedman's test. For the scale, we have the Cochrane Q test for the dichotomous, or yung yes, no, or true or false. So to do that one, we'll go the non-parametric, and we have here the RM factor, the repeated measure factor, and then we will check here that we have the non-parametric test. We have here the Friedman test here, and the chi-square, the degree of freedom is 3, the p-value is 0.009. So it means it is still significant. So based from that result, whether we use the non-parametric, there is really a significant difference among the treatments. And this is my references. Thank you so much for listening. If you have some comments, suggestions, please comment down below. Click subscribe for more explanations or discussions on statistics.